Hello class, this is Ms. Riggins with today's video on section 7.5, right triangles, inverse trigonometric functions. As you're watching the video, please remember to write down notes, especially including any important information, equations, statements, graphs, or formulas. Feel free to pause, rewind, or even replay the video as often as you need so that you can get a more clearer understanding of what's going on in the video. When you have concluded watching the video, write down a brief summary in your notes of what occurred in the video and submit that summary as well as a top question via the online whisk form before class. All right, let's begin. If you recall, in the past few videos, we've been talking about the sine ratio, cosine ratio, and tangent ratio, which ends up talking about the sine, cosine, and tangent functions, where we are given an angle and determining the corresponding sine ratio, cosine ratio, or tangent ratio. Well, today we're going to switch it up a bit. Today we're not going to be given an angle and asked to determine the ratio. We're going to be given a ratio and asked to determine what is the angle that measures that will give me that ratio. So for example, here's a problem. Here I have a right triangle. And this is actually a 3-4-5 triangle, one of those Pythagorean triple triangles. And the issue here is I have the side lengths, so I have the ratio. So let's take a look at the sine ratio of angle theta, which is opposite over hypotenuse. The opposite is 3, opposite leg is 3, the hypotenuse is 5. So the sine ratio for that angle is 3 over 5, or exactly 0.6. But the question is, what angle measurement of theta gives me a sine ratio of 3 over 5, or 0.6? Well, some of you may be able to roughly estimate what theta must be because we know that the sine of 30 degrees is 1/2 and the sine of 45 degrees is 0.707. So since 0.6 lies in between 0.5 and 0.7071, i.e. square root of 2 over 2, then that must mean that my angle theta would have to lie in between the two angles that produce those respective values, which in this case is 30 degrees and 45 degrees. So far I know for a fact that theta should be somewhere in between 30 and 45 degrees. Another way to get a closer estimate is to take a look at the graph of the sine function and figure out which y value will produce an x value, which x value produce y values of 0.6. Well, if I go over here and 0.6 may be somewhere around here, and I would take a look at the points on my graph where I have a y value of 0.6, I can see that there are several points on my sine function, which is periodic, which would have y values of 0.6. But we're going to look at a specific domain of values because remember we're dealing with a right triangle and an angle in a right triangle, in this case, which is an acute angle. So in other words, we're looking at angles that are between 0 and 90 degrees. So actually we're looking at only this region of the graph because those are the only angles that are between 0 and 90 degrees. Okay, and my drawing wasn't exactly correct, but you get an idea. So there is one value that reaches that, and that value looks to be somewhere, if we can take a graph right here, it looks to be somewhere over here, which is consistent with between 30 and 45 degrees, because this looks like somewhere less than a half, but more than a third. To get a more exact value, we could also use the numeric features of our calculator and just plugging and chugging different values of angles and determining which one would give us 0.6 ratio. And we can do that by basically plugging in different values between 30 and 45. And when I do that, I do find that numerically I can find that as being 36.87 because that would give me a sine value of 0.6. Now these strategies are good strategies, except they take a lot of time, and there has to be an easier or quicker way for which we can find this value without having to plugging in a whole bunch of different values. And there is. But before we determine that way, I want to show you something, explain something that will help us determine that. So there in your book, it talks about when you have an x value, i.e. the ratio value, and this is important to know that x no longer represents the angle measurement, but x represents the ratio value, and more specifically, the sine ratio value. When the sine ratio value is between 0 and 1, then we can define a function, which we call, and there's two ways they call it either arcsine of x, or they call it sine inverse of x. So you're going to see it written both ways, and make sure you recognize those. I think SAT uses arcsine, whereas calculus AP may use sine inverse, or both. But anyway, arcsine of x, or sine of x, is basically equal to the angle in the right triangle whose sine is x. So the question is, are we considering only those values of x between 0 and 1? Well, if you recall, we're only looking at angles that are between 0 and 90 degrees. So therefore, the angles that are between 0 and 90 degrees only have y values for the sine ratio between 0 and 1. So whatever this angle is that they're going to give us, this angle will have to be between 0 and 9 degrees including. Okay, so this is a little bit different because no longer is our domain every single x value, but here our domain is restricted to being between 0 and 1 and not including 0 or 1. So that means our answer should be an angle in between 0 and 90 degrees and not including 90 degrees. So basically, another way to look at it, for theta in a right triangle, actually I need to take out that because we're not including 0 and 9 degrees, in this example. An angle in between 0 and 9 degrees, since the sine of theta would be equal, let the sine of theta equal some value x, that means that the theta is equal to either arcsine of x or sine inverse of x. And that's an important relationship to remember. So write that down, put a real big box around it or something, because that's important to recall. So what does this mean for us? Well, let's take a look at, I do want to go over and take a look at some calculator issues so we can have an idea. So one of the things to note is, first of all, we have to make sure our angle measurement is in the correct angle measurement, which is degrees for this unit. So we go up here into our scratch pad or to our calculator document and see if the angle is in degrees. If it's not, please change it. Now, to use the arcsine function or the sine inverse function, we would have to go to the trig button, which is right next to the number 7. And we pull up the trig button, we see in the top our sine, cosine, tangent ratios, as well as some other trig ratios. But at the bottom is the resulting arcsine, arccosine, arctangent, or the inverse trigonometric functions. So to use sine inverse, we would have to click sine inverse. And our x value now no longer is an angle measurement, but a ratio of sine inverse of 0.6. And our answer will give us an answer, which is, since our angle is in degrees, that answer is our degree measurement. So if I were to go in here and put sine of, if I were to go in here and put sine of 36.86 something degrees, I'll get out at exactly 0.6. Now let's take a look at the graph. If I go to my scratch pad and either the graphing function, or if I go to a graphing page on the calculator, if I go up here back to the menu, I see that my angle is in radians. So we're going to have to change that graphing so that we have it in degrees. And you can't do it with the method we use to change the other one. We have to go to the menu. So hit menu and then go into settings. Whenever you're on a graph page, when you hit menu, you can change the graph settings. And as you can see, even though our geometry angle is degree, our graphing angle is radian. So we have to change that to degree. And I'm going to make that default. And I'll say OK. So now when I go back up here, it's in degrees. Now, if you recall, for our inverse sine function, the domain is from 0 to 1. And our range is an angle measurement, which is from 0 to 90. So I'm going to change my window to represent something like that. So I'll go to menu 4 to change the window settings. Remember, our domain is from 0 to 1. So I'm going to just put a -1 to 1. just so you can see something. And our range is for the angles is from 0 to 90 degrees. I'm going to put negative 90 to positive, let's do it to 180. I want to show you something. Okay? I know you're saying, why are you doing that? Because I wanted to show you what it looks like outside of 0 and 90 degrees. So when I hit OK, now I have a window set, and then I can type in the sine inverse function by going to trig, hitting the sine inverse, and saying x. Now, as you can see, oh, okay, let me pause a second. Okay, I'm sorry, I didn't realize your calculator, they had made some improvements on this. So I actually changed the window from -1 to whatever to -2 to 2 for the x values, and the y values between -180 and 180. And when I did this, you can see, of course, the function is not defined in values. There is no function. Now, normally our x values are between 0 and 1, but our calculator made some improvements and realizes that you can actually define it from -1 to 0, -1 to 1, because it's just a reflection across the origin of this graph. So here, this sine inverse function in your calculator can take any value between -1 and 1. And it will spit out a value between -90 and +90, okay? And that's because it's basically taking this part of the graph and reflecting it across this part of the graph. Okay, so now that we got that fixed, now let's go back to something else. I know some of you may be saying, well, I know this works here. Now we said this is how it's defined for between 0 and 90, theta between 0 and 90, but our calculator can make it even all the way up to 180. So anyway, back to what I was talking about. I know some of you may be saying, well, that's all nice and good for sine inverse, but what about cosine and tangent, since we're dealing with cosine and tangent? And we do have a chart that goes through that relationship as well. We call it the arc cosine or the inverse cosine. It's the same notation except it involves cosine. And the same thing with tangent and the same definition. And so these ratios exist as long as your theta is either on paper in between 0 and 90 degrees, or your calculator might have been inspired can take it if it's between -90 degrees and +90 degrees. Okay, all right, so that video was a little bit longer than I planned, but I did show you how to use the calculator at your request. So that's it. Thanks.